Welcome back दोस्तों. In the previous section we learned x coordinate refers to distance from y-axis and y coordinate refers to distance of point from x-axis. Other than that, we learned slope of a line is denoted by the symbol m. Its value is equal to tan theta, where theta is the angle made by the line with positive x-axis. Also, another formula for slope was y2 minus y1 upon x2 minus x1. So these were the concepts we learned in the previous section. So let us learn our first concept for today, which is distance formula. Distance formula is used in coordinate geometry to find the distance between any two points. So, suppose we have one point P, let us say x1, y1, and another point Q, let us say x2, y2. Then, distance formula says that distance between P and Q is given by the formula PQ distance. This is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This can also be written as square root of x1 minus x2 the whole square plus y1 minus y2 the whole square. It is one and the same because on squaring x1 minus x2 the whole square is same as x2 minus x1 the whole square. So let us see how we prove it. To prove it, let us consider x and y axis. And we consider one point, let us say P having coordinate x1, y1 and another point Q having coordinate x2, y2. Now, we want to find the distance PQ. To find the distance PQ, let us think how we will prove it. We want to prove this result. Distance PQ is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So the simple trick here is to drop a perpendicular here and another perpendicular from here. So this perpendicular is perpendicular to the x-axis and this perpendicular is perpendicular to the y-axis. Now this angle is right angle because angle between x and y-axis is 90. So angle between their perpendiculars will also be 90. Let us call the point joining the perpendiculars as R. Now in the previous section we already proved QR, this distance is nothing but y2 minus y1. So let me call this distance as y2 minus y1. Why? Because QR is equal to this distance minus this distance. This distance we proved in previous section, it is y2 and this distance is y1. So y2, the big distance, minus y1 is QR distance, which is y2 minus y1. Also, in the previous section we proved this PR distance is nothing but x2 minus x1. Why? Because PR is this distance, which is x2 minus this distance, which is x1. So, by Pythagoras theorem, now we can easily say PQ square is equal to PR square plus QR square. So we can say PQ is square root of PR square plus QR square. So we can say PQ distance comes out to be square root of PR square. What is PR? It is x2 minus x1. So we can say PQ comes out to be square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So this is the proof of distance formula. Simple enough. We just use Pythagoras theorem, PQ square is QR square plus PR square. And that's it. We prove distance formula. So far, we have learnt about x coordinate, which is distance from y-axis, y coordinate, which is distance from x-axis, and slope of a line, which is tan theta, which is y2 minus y1 upon x2 minus x1. Also, we learned distance formula between any 2 points P x1 y1 and Q x2 y2. Distance PQ is given as square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So let us use these formulas to solve some simple problems. For example, if we want to find the slope of a line, let us say something like having 2 points. Let us say one point is P having coordinate 2, 3 and another point Q having coordinate, let us say 1, 2. So in this case, what is the slope of this line? So we will use our slope formula, which is m is equal to y2 minus y1 upon x2 minus x1. So let us say we call one point P having coordinate x1 y1 and another point Q having coordinate x2 y2. Then in that case, what is the value of y2? y2 is the coordinate which is y coordinate for point Q, which is 2, minus y1 is the y coordinate of point P, which is 3. So 2 minus 3. y2 minus y1 means 2 minus 3 upon x2 minus x1. x2 in this case is 1 minus x1, it is 2. So our slope will come out to be minus 1 upon minus 1, which is 1. So the slope of this line is 1. That means this line makes a acute angle with the positive x-axis. So it will make 45 degrees with the positive x-axis. Why? Because slope is given by the formula tan theta, and tan theta is 1. Means theta, the angle made by the line with positive x-axis, it is 45 degree, which in radian we can say pi by 4 radians. So this is how we will use the formula for slope. If in this question we want to find distance PQ, so we will use distance formula, which is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. What is the value of x2 here? x2 refers to the coordinate, which is x coordinate of point Q, which is 1 in this case. x1 in this case is 2. So 1 minus 2 the whole square plus y2. y2 refers to the y coordinate of point Q, which is 2 in this case. y1 refers to the y coordinate of point P, which is 3 in this case. So our distance PQ comes out to be square root of minus 1 the whole square plus minus 1 the whole square, which is nothing but square root of 1 plus 1, which is 2. So our answer in this case, distance PQ will come out to be root 2 units in this case. So this is how we will use slope formula to find the value of slope, and by using the value of slope we can find the angle made by the line with the positive x-axis. Also we can use distance formula directly and get the distance between any 2 points. Let us now move on to the most important topic of this chapter, straight line, which is equation of a straight line. So we have various forms of equation of straight line. So let us see these one by one. So our next topic is equation of straight straight line. Equations of straight line is a equation which is satisfied by all the points lying on that line. So what do we mean by that? A equation, let us say x plus y is equal to 1. So this equation will be satisfied by all the points lying on this line x plus y is equal to 1. For example, if I consider one point as 0, 1, whose x coordinate is 0 and y coordinate is 1. So x coordinate x, which is 0, plus y coordinate 1, 0 plus 1 is 1. So we can say 0, 1, a point which is lying on this line x plus y is 1 is satisfying the equation of the line. Similarly, another point, let us say 0.5 plus 0.5 is 1. So we can say 0.5, 0.5 is a point which is lying on this straight line, which is satisfying this equation. Also, let us take one more point. 1 plus 0 is equal to 1. That means this point 1, 0 also lies on this line and its equation is being satisfied. So if I plot this line, let us say, so we have 1.0, 1, which is this point. Next point 0.5, 0.5, which is, let us say, this point. This is 0.5 units. This is also 0.5 units. Our final point 1, 0, which is, let us say, this point 1, 0. So all these 3 points are lying on the same straight line whose equation is given as x plus y is equal to 1. So any point lying on this line will satisfy this equation. Then we can say this equation is the equation of the required straight line. So this is the meaning of equation of a straight line. Any point on that straight line will satisfy the equation of that straight line. Let us take another example. Let us say we have another line. This is a line which is passing through the origin. Let us say it makes 45 degrees. So in that case, I can say its equation is y is equal to x. Why? Because we can have various points 0, 0, y is equal to x, 0 is equal to 0. So this point is satisfying that equation. Another point, let us say 1, 1, x and y both are equal. So 1, 1 also satisfies the equation of the line. Another point, let us say 2, 2, x and y both are equal. X coordinate and y coordinate are equal. So it satisfies the equation y is equal to x. Similarly, another point, let us say -1, -1 satisfies this equation of line. So we can say y is equal to x is an equation of line which satisfies all the points lying on that line. So this is the meaning of equation of a straight line. Now let us try to understand various equations of straight line. So now we want to derive various general forms of equation of straight line. What are the various forms? Let us say we have slope point form, we have 2-point form, we have slope intercept form, double intercept form, normal form or perpendicular form, general equation of a straight line. So we have various equations of a straight line. Let us see them one by one. Let us first take our first equation of straight line, which is in terms of slope and a given fixed point on that line. To use this slope point form, first let us see the first equation, which is slope point form of the given line. So we want to derive the equation of the straight line in terms of the slope and a given fixed point on the line. So what is the general method to find the equation of a straight line? The general method is to use the parameters. One parameter here is slope, which is denoted by the symbol m. Another is point in this case. Let us denote a fixed point by the coordinate x1, y1. Now, in terms of m, x1 and y1, we want to get the equation of a straight line in slope point form. So, in all the equations of straight line, we always have a general point. And what is that general point? General point is x, y. So, let us say we have a general point P, which is x, y. So, we have three things: general point x, y, a fixed point on that line x1, y1, and the slope of that line is m. So what are the three things that we have? One is the general point, which is x, y, which is lying on that straight line. We have a fixed point x1, y1, which is also lying on that straight line, and the slope of that straight line is m. To understand this, let us draw the graph. So suppose we have a line and the slope of that line is, let us say, m. The general point on that line, let us say P, which is x, y. And the fixed point, let us say, is Q, which is x1, y1. Now, I want to find the equation of this line. So what formula will I use? I will use the formula for slope m, because we want slope point form. So slope m, we know it is given as y minus y1 upon x minus x1. So y minus y1 upon x minus x1. So that's it. This is the equation of straight line, which is having slope m, fixed point x1, y1, and general point xy. So this is the equation of straight line in slope point form. Let us take an example to understand how we use this formula for equation of straight line in slope point form. To understand this, let us take the example of a line whose slope is, let us say, 1, and it passes through a point, let us say, which is having coordinate 2, 3. So this line passes through point which has coordinate 2, 3. It has slope 1. What is the equation of this straight line? So let us use this formula. So m, which is the slope, is equal to y minus y1 upon x minus x1. So slope in this case is given as 1, which is y minus y1, which is nothing but 3 upon x minus x1, which is nothing but 2. So we can say y minus 3 is equal to x minus 2. So on rearranging, we can say x minus y, if I take this y on the other side, is equal to minus 1. Because minus 2 on the other side becomes plus 2 minus 3 is minus 1. So x minus y plus 1 is equal to 0. This is the equation of a straight line having slope 1 and passing through the fixed point x1, y1, which is 2, 3. So this is how we will use slope point form to get the equation of a straight line. So in slope point form, we have slope m of the line and a fixed point which is x1, y1. So this is one form of equation of a straight line. Slope point form, because slope is m and point is x1, y1. Always in any equation of a straight line, we will have a general point which is x, y. So this is how we use slope point form. M is equal to y minus y1 upon x minus x1. Then let us move on to our next equation of straight line. This is 2-point form. So 2-point form of equation of a straight line. So from the name itself, we understand 2 point means there will be 2 fixed points which will be given to us. Let us say 1 point we are given as x1, y1 and another point we are given as x2, y2. We all know 2 given points determine a straight line. So these 2 points are given to us. Also, as I already said, we always have general point on the line. What is the general point? Let us say P. It is x, y. So we have 3 things. One is general point P, which is x, y. Let us say one fixed point Q, let us say, which is x1, y1, and another fixed point, let us say R, which is x2, y2. Now, if I draw x-axis and y-axis and I draw a straight line. On this straight line, I have one point which is P, which is x, y. Another point which is Q, which is x1, y1. And finally, we have one more point on the same straight line, which is x2, y2. So we want to find the equation of this line on which we have one fixed point because we have 2-point form. That means we have 2 points. Let us say one is Q, which is x1, y1. Another is R, which is x2, y2. So I want to find the equation of this line. In this case, the slope is not given to us. But we can say slope of PQ equals slope of QR. Isn't it right? Slope of PQ equals slope of QR. Because PQ lies on the same straight line, so its slope will be equal to QR because Q and R are also lying on the same straight line. PQ and QR, they denote one and the same straight line. So we can say slope of PQ equals slope of QR. Now what is slope of PQ? It is y minus y1. So we can say y minus y1 upon x minus x1. This is the slope of PQ. That equals slope of QR, which is y1 minus y2 upon x1 minus x2. So this is the equation of straight line in 2-point form. So if you see carefully, here we have 2 points. One is x1, y1, which is a fixed point. Another is x2, y2, which is another fixed point. So this is how we use the equation in 2-point form to find the equation of a straight line. Let us take an example. So for example, if I want to find the equation of line which passes through one point which is 1, 3 and another point which is, let us say, 2, 5. So what is the equation of line which passes through these 2 points? So we will use this slope point form. X and y are general point parameters. So we can say y, let us say this is x1, y1. And let us say this is x2, y2. So what is our equation? Y minus y1. So y1 is in this case 3. So y minus 3 upon x minus x1. x1 in this case is 1. So x minus 1. That equals y1 minus y2. y1 in this case is 3 minus y2, which is in this case 5, upon x1, which is in this case 1, minus x2, which is in this case 2. So our equation of straight line is y minus 3 upon x minus 1 equals minus 2 upon minus 1. Minus 2 upon minus 1 is 2. So we can say y minus 3 upon x minus 1 is equal to 2. This is the equation of straight line. If we want to simplify further, it will come out to be on cross multiplication. Y minus 3 is 2x minus 2. So 2x minus y plus 1 equals 0. This is the equation of straight line which is passing through these two given points. So what we have done here, we have taken this y on the right side, so 2x minus y, and this minus 3 on the right side, so plus 1. So 2x minus y plus 1. This is the equation of straight line passing through point 1, 3 and another point 2, 5. So this is how we will use 2-point form to find the equation of straight line. So in this section we learned about two formulas. One is slope point form, in which we are given slope, which is m, that equals y minus y1 upon x minus x1. Here we have slope of the line, which is m, and fixed point x1 y1. Another formula which we learned is 2-point form. Here we are given 2 points, x1 y1, which is one fixed point, and x2 y2, which is another fixed point. Its equation is y minus y1 upon x minus x1 is equal to y1 minus y2 upon x1 minus x2. So this is how we use the equation of straight line in two forms. One is slope point form and 2-point form.